Thinking of building your own gaming PC but feel lost with all the CPU names and numbers? Confused between Ryzen, Intel, i5, i9, cores, threads? What does it all really mean? In this video, I'll break down exactly how to choose the right CPU for your gaming PC step by step, in simple terms. Whether you're a beginner or a tech-savvy gamer, by the end, you'll know exactly what to look for, what to avoid, and how not to waste your money. Firstly, the CPU. The CPU is the brain of your computer, and it's the second most important component for gamers. To choose the right processor, you first need to understand how CPUs are named. There are two major CPU manufacturers, AMD, which makes Ryzen processors, and Intel. Both Ryzen and Intel processors follow a similar naming structure. First comes the company name, followed by the processor tier. For example, Intel Core i3 or Ryzen 3, entry-level budget processors. Intel Core i5 or Ryzen 5, great for gaming. Intel Core i7 or Ryzen 7, good for gaming, streaming, and video editing. Intel Core i9 or Ryzen 9, high-end processors for demanding workloads. These are often overkill for gaming. Next, you'll find the generation number. Intel processors are numbered by generation, first gen, second gen, and so on. Ryzen CPUs follow the same pattern. However, keep in mind that some generations are based on the same architecture as the previous one, with only slight improvements. So while a higher generation number usually means a newer and better processor, that's not always a massive jump in technology. Still, a high-tier CPU like a Ryzen 9 or Core i9 from an older generation may outperform a newer Ryzen 3 or Core i3. And vice versa, a newer entry-level CPU might beat an older high-end one in some tasks. That's why you need to balance both the CPU tier and generation. After the generation number, you'll see a 3-digit model number, which tells you how powerful that CPU is within its tier. The higher the number, the better. Now, let's talk about the letters at the end of the CPU name. For Ryzen, X, higher clock speeds and slightly better performance. G, integrated graphics, APU. GE, integrated graphics plus low power usage. XT, improved version of the X, X3D, large cache for amazing gaming performance. U, for low power laptops. HS, high performance for laptops but with better power efficiency. HX, maximum performance for AMD laptops. For Intel, K, unlocked for overclocking. F, no integrated graphics, requires a dedicated GPU. KF, overclockable and no integrated graphics. T, low power version. H, high performance laptop CPU. U, ultra low power for slim laptops. HX, highest performance laptop CPU, close to desktop level power. By the way, all Ryzen processors are unlocked for overclocking and do not come with integrated graphics, except for the ones with a G at the end of their name. On the other hand, all Intel processors come with integrated graphics, except for those with an F in their name. Also, most Intel CPUs cannot be overclocked, unless they have a K at the end of their model name. Now that we understand how to read CPU names, let's look at their internal components. A CPU consists of cores and threads. Cores execute tasks, and threads allow them to run multiple tasks at once. If a core supports 2 threads, it's called hyper-threading, which improves multitasking performance. The number of threads is usually equal to or double the number of cores, but not always. Modern Intel CPUs often use 2 types of cores: performance cores, P-cores. These support hyper-threading and handle heavy tasks. Efficiency cores, E-cores. These don't support hyper-threading and handle lighter tasks. For example, the Intel Core i5-13400 has 6 performance cores, each with 2 threads, and 4 efficiency cores, each with 1 thread. That gives you a total of 10 cores and 16 threads. The number of cores matters a lot, especially for heavy tasks like editing or streaming. But in gaming, single-core performance is sometimes more important than the total core count. So, what defines strong, single-core performance? 2 key things. 1. Clock speed. Look for CPUs with speeds between 3.8 and 5 GHz. The higher the better, especially for gaming and demanding applications. 2. L3 cache, memory cache. This is a super fast small memory built into the CPU. A cache size between 20 and 40 MB is ideal for high performance in games and heavy workloads. Also remember, Intel's modern CPUs use E-cores and P-cores. P-cores do the heavy lifting. E-cores handle background tasks and save power. Even if you choose a CPU with a great number of cores, good clock speed, and large cache, it's always best to check benchmarks to get a real-world idea of the performance. If you do not understand something from the video, please like and write it in a comment. Also, when buying a CPU, you need to be very careful, because every processor requires a specific socket to fit into a motherboard. You can't just install any CPU into any random motherboard. Each motherboard has a dedicated socket that's compatible only with certain generations of processors. For example, in the case of AMD Ryzen, we have the AM4 socket, which supports all Ryzen CPUs from the 1st to the 5th generation. This makes AM4 one of the best sockets in terms of upgrade potential, because it allows you to install CPUs from 5 different generations. Then we have the AM5 socket, which supports Ryzen CPUs from the 7th to the 9th generation. There is no desktop socket for the 6th generation, as it was released exclusively for laptops, so we generally don't need to worry about it. As for Intel, the 6th and 7th generation processors use the LGA 1151 socket. The 8th and 9th generations also use LGA 1151, but in a newer version known as LGA 1151 V2, which is not backward compatible. The 10th and 11th generation Intel CPUs use the LGA 1200 socket. Finally, the 12th, 13th, and 14th generation Intel processors all use the LGA 1700 socket. So always make sure to check the socket type and compatibility before buying a CPU or motherboard. By the way, I will make a video like this dedicated to how to choose the best motherboard. If you found this helpful, don't forget to like the video, share it with a friend, and subscribe to my channel. Stay tuned for upcoming videos on monitors, graphics cards, and all things tech. See you next time.